Okay, I'm going to go over some of the concepts for Chapter 3 test review over relations and functions. Okay, when you're given a t-chart or a horizontal chart, notice you have x, y. Okay, here's your x, here's your y. Remember, your x's are your domain, your range are your y. So when I ask for a domain or range, you write your domain, and you put them in order, 0, 1, 2, 3. Oops, hold on. Make the bracket the same. And then your range, again, are your y values. So 1, 2, 3, 4. And it is a function because none of the x's repeat, or you could say for each x there is exactly one y. Okay, let's pretend we have a graph like this, and I want you to give me the domain and range. Well, first of all, when you're talking about your domain, let's look at where your x's are, right here and right here. Now, if you notice, your x's, that's pinpoint here, so this is 1, 2, 3, 4, 5, so this is at -5, and this is at +6. So your domain is going to be between -5 and +6, and we know it's your x values. We know that this dot is solid, and we know that this dot is solid, so therefore your x's are going to be greater than or equal to -5, or less than or equal to 6. Now again, we're talking about your x's, so your x's start here and get bigger according to the graph. And here your x's start at 6 and get smaller, so it's just like an AND statement. Alright, now when you look at your range starts from the lowest point, which is, well, let me make that a little bit bigger. It starts from right here at your lowest point, and then it goes all the way up to your highest point. So these are your range. This is your y values. So if you notice, oops, let's undo that real quick. If you notice, it's from this mark here, so that's at -6, and then up to your highest mark, which is right here, and that's up to 4. So if you put that in order for your range, let me kind of scoot this up a little bit. When we talk about our range, our lowest point was -6, our highest point was 4, and we are talking about the y values. And so from this graph, if you notice, your picture goes up this way. So I want the y's to get greater than -6 or equal to. And then from here, this is the highest point right here, and notice the rest of your graph goes down. So your y's are less than 4. And this right here is your domain and range for that graph. Now, if you want to, let's take a look at just the picture by itself. If you look at this right here, if you do a vertical line test, all of these, it passes through the graph one time. So therefore, it is a function based on the vertical line test. Okay, let's say we have an evaluate problem. As soon as you see the word evaluate, hey, that means, hey, plug this in for x. So basically, the only thing you have to do is 3 times 2 minus 1. Well, 3 times 2 is 6, minus 1 is 5. So when you write it, f of 2, because that's what you replaced, f of 2 equals 5. So remember, you're just plugging this in. And remember, if there's a square there, all that means is this. If I have 3 times 2 squared minus 1, you square the 2 first, so that's 4. And you get 3 times 4, which is 12, minus 1, which is 11. So it depends on what the problem is. But as soon as you see evaluate, you're plugging it in. Now, when you have f of x equals x plus 1 and g of x equals 2x minus 2, let's say you want to find the result of these two functions being subtracted from one another. Well, the only thing you have to do, now these are your given, all right? Only thing you're going to do is plug in the correct portion. So f of x is x plus 1, put in parentheses, minus parentheses, g of x is 2x minus 2. Now, in this one, there's a minus there, so you have to distribute that minus. Remember, that's a minus 1. So this is x plus 1 minus 2x, and then distribute it again. So -1 times -2 is a plus 2. Now you simply combine like terms. X minus 2x is a negative x, and 1 plus 2 is plus 3. And that is your result. Now in this particular problem, I want you to graph this equation given the domain. Well, remember, your domain are your x values. So the only thing you're going to do is plug these in for x and solve for y. For instance, if I plug in 1 for x, that leaves me 1 plus y equals 2. Well, when I subtract 1, I get y is equal to 1. So when x is 1, y was 1. So I'll plot that point, 1, 1. The next one, I want to do when x is 2. So you get 2 plus y equals 2. Subtract 2, and you get y is equal to 0. So when you plug in x, 2 for x, you get a y value of 0. So at 2, 0, which is right there. And then finally, when you do the 3, you're going to plug in the 3 now. So you get 3 plus y is equal to 2. Well, when you subtract that 3, you end up getting y is equal to negative 1. So it creates a coordinate point of x of 3 and a y of negative 1. So at 3, negative 1 connects right there. And basically, you just connect the dots and make a line. Now, what if I give you an equation like this and I ask you to solve it? Well, remember, this means absolute value. So anything coming out of it is going to be positive. So what you need to do is create a t-chart. All right? Make up some x's. It doesn't matter what they are. Let's try, let's say negative 2. Let's try negative 1. Let's try 0. And let's try 1 and 2. Those sound like good numbers. When I plug that in, look what you end up getting. The absolute value of 2 times negative 2. All right, so we want the absolute value of that. Well, 2 times negative 2 is negative 4. And the absolute value of negative 4 is 4. So I can plot that point negative 2, 4. So negative 2, positive 4 is up here. Then I'm going to do the same thing with negative 1. Again, absolute value of 2 times negative 1. Alright, so 2 times negative 1 is negative 2. And the absolute value of negative 2 is positive 2. And when you plug in 0, 2 times 0 is 0. And then you do it again, so absolute value of 2 times 1. Alright, so 2 times 1 is 2. So the absolute value of 2 is 2. And you notice this kind of repeats. So we go negative 1, 2, 0, 0, 1, 2, and 2, 4. And that creates this graph here, called an absolute value function. And you just connect it. And that's how you basically have to come up with your own points in order to create a graph. You already have the equation, so you plug in the x to get the dependent variable of a y. Now what if you're faced with another equation? Let's say y equals x squared minus 1. In fact, let's change this. I don't want it y equals. Let's change it to f of x equals x squared minus 1. Only, again, you're just simply making a chart, whether it be a horizontal or vertical. Just plug in some numbers. So let's try a couple negatives. Let's try negative 2. Let's try negative 1. Let's try 1, and then let's try 2. Okay, well, if you plug in negative 2 here, what you end up getting is negative 2 squared minus 1, so that's 4 minus 1, which is 3. If you plug in a negative 1 squared minus 1, that's 1 minus 1, which is 0. Alright, so basically what ends up happening is you're squaring this number. And you just basically, use a graph and you plot those points. Negative 2, 3. So negative 2, 3 is going to be somewhere up here. Negative 1, 0 is going to be right here. So it's going to graph something like this. So don't be afraid of just coming up with some x's and plugging them in to find y. Now, when doing a piecewise function, what you want to look at is you have f of x, which is another name for y. So what you end up having is y is equal to x, which is what I've put right here. And you also have y is equal to x plus 1, which is right here. Now, if you look at the restrictions, it's telling you what x values you can use. The first one is going to use all the x's that are less than or equal to negative 1. Well, if you notice, that's what I created right here. So let's plug those in. So if I get y equals, I'm going to plug in -1 for x. Y is equal to -1. So I place it right here. And if I plug in -2, I get y equals -2. Same thing for the -3. Now if you notice, this creates a coordinate point of -1, -1, which is plotted right there. Now when I plug in -2, it's plotted, say, about right there, and of course -3, -3. Now I know that I can, it's all the x's that are less than or equal to. So I'm going to connect that line going away like this. Alright, and then that endpoint is solid because it's included. Now let's look at the next one. These are all the y's, or all the x's that are greater than or equal to 3. So that's what I chose, 3, 4, 5. Alright? So when I plug this in to y equals, and I'm going to plug in a 3 plus 1, that gives me 4. If I do that again to y equals 4 plus 1, that gives me 5. And if I do the next one of 5 plus 1, that gives me 6. So that creates a coordinate point of 3, 4. So 3, 4, it's going to be about 1, 2, 3, and then up 4, about right there. And then 4, 5 would be one step further, and then 5, 6 would be even one further than that. And we connect it going away this way. So this creates a piecewise functions using both of these equations and then of course both of our domain restrictions.